All right, section 4.3 actually takes the last section about looking at prime factorizations, and it looks for pieces of information called greatest common factors or greatest common divisors and least common multiples. Okay? We're going to start with the greatest common divisor or greatest common factor. This is the largest number that divides all the numbers in the set. All right? So if you have two numbers, you're looking for the biggest number that divides them both, which means, in theory, it's usually a smaller number than you've already started with. So what you have to remember about this word greatest is that it is an adjective that describes what comes next. So this is your English inside of math for the day. I do know a little bit of English terminology. It's an adjective. So the word greatest doesn't mean it's simply a big number. It's a descriptor of what comes next. It has to be a divisor, and it's simply the biggest divisor that there is. Now, we've talked already in both other sections about this next definition, relatively prime. Relatively prime just means that the two numbers don't have any factors in common except the factor of 1. That's their greatest common factor. So we're going to talk about different methods for finding out if numbers have factors in common or if they're relatively prime. So the first one is the intersection of sets method. The way this method works is you list all the divisors of each value and you pick the one that's the biggest. That's how exciting it is, just like there. So you don't list primes. You're not doing anything about prime numbers here. You're just listing all the things that divide it. So this is like our example where we were doing the trees, right? The rows and columns of trees. We weren't looking for anything about being prime, right? We were just looking for any numbers of rows and trees that worked. So if we're looking at the factors for 12, not prime factors, but all the factors, we'll start with the number 1. What's the next number that divides 12? 2. And then 3, 4, 6, and 12. So this is a list of all of the divisors of 12. And then we do the same thing for 15. List all the factors that divide 15. It starts with 1. They always start with 1. What comes next? 3, 5, and 15. And we look at our two lists and we examine them very closely, and we very quickly find out that the biggest number common to both lists is the number 3. So the greatest common divisor is 3. Sometimes it's called the listing method. Okay? But you're looking for intersection or a list of what they have in common to see what we can take a look at.